Question number 16 of the PhilNITS FE afternoon portion of the exam. In this question, we are given a function called m_sine, which calculates and returns the approximate value of sine of x for the argument x using the Maclaurin expansion. The program calculates sine of x using the approximate formula below. This one here. The exclamation point is the factorial symbol, and n is the first integer for which this expression is satisfied. Okay, I think that this question is a really difficult question, a tough question that in my case I had to try out so many of the possible answers, which I think eventually I was able to arrive at the correct answer, but only after trying out so many that I think it used up quite a lot of my time. And if we are to recall that there are weights to the questions, I'm thinking that this is one of those questions that would have a heavier weight. Now, the way to answer this is to, of course, look at patterns, because if you just think about what is this Maclaurin expansion and all these expressions, all these writings, it might be too difficult immediately as an impression. So what I did was to look for patterns, something that we can understand from the equation, and I think that eventually I was able to see that this part here and this part here would be the ones that we can plug in the values. Okay, now there's also this part here, and I think this part where you got the less than or equal symbol would be crucial when we answer one of the blanks in the program. Okay, so let's look at the program right now. We got two blanks, A and B, and if we are to look at the answer group, we can find that for blank A, there's really only two possibilities. Let me just make this a little bit smaller. So it's either less than or equals to EPSI or greater than EPSI. So once we can choose which between the two is our answer, then at least we'll be able to answer this part here. But the next problem would be blank B, where as you can see there are several possibilities. There are, in this case, 5 possibilities, and I think I ended up trying out pretty much most, if not all of them, to arrive at the correct answer, which is H. Now, to understand how I eventually got the correct answer for blank A, we should look at the program and also the description. Okay, in particular this part here where we have the less than or equal to sign and 10 negative 7, we have EPSI, and if we check what is EPSI, we see that it's this one, right? And so this one corresponds to this. However, we might be wondering why it's greater than EPSI. And I think that if we check what is it that we're doing in the while condition, in the description it says that we are gonna stop once we've satisfied this condition. Okay, so what that means is, if we are asking when are we gonna stop, it has to be less than or equal to EPSI. But if the question is how long are we gonna do this, our answer is as long as we are greater than EPSI. Okay, so that means that there is a change in the way we should think about um, how we can use this part here to know that we have not satisfied the expression. Okay, so that's why this one here says that it has to be greater than EPSI so that we can continue on doing the instructions inside the loop, because we haven't satisfied the condition that says that we should stop. Okay, so having figured that out, I then needed to know what would be the correct answer for this one. And we need to remember this part here where you got the factorials, because we will need to plug in the values and see whether we can arrive with this output too. Okay, so the next problem I had was I couldn't really quite remember what a factorial was. I thought that maybe it should be 3 plus 2 plus 1, and eventually, while trying out the possibilities, the possible answers, I thought that it's gotta be 3 times 2 times 1. So that's how I figure out that it is indeed like that. If it's 3, 3 times 2 times 1. If it's 5, 5 times 4 times 3 times 2 times 1. That's how you got 120. Otherwise, I won't get an answer. The equations would give me something, but I won't get this one as the output. Okay. Now, next, the problem is choosing which would be the answer for the next column. In my case, I tried out, I think, pretty much all. And if we are to look at the answer for letter F, our equation would be this instead of the correct answer, which is this. And I think that if you try it out and really find that at the end you don't get this, then it's wrong. But also, you gotta think about, is there a way to know what would be the next likely answer, right? And for example, would it be something related to the K, or would it be something related to the X, like that? So at least you can narrow down your search. But eventually, I still had to try out pretty much all, if not all, to arrive with the answer. So I think in my case, it took quite a longer time. That's why I was saying that this is a pretty difficult question. Still, let's plug in the values. We need to know what K is, and the program says that to get K, what we need to do is do a plus 2. If the current value at the start is 1, then we need to do a plus 2. That's why if we're starting out, then we get 3 as our K, and then we plug in the values so that our Vn in this case would be uh, X. But of course, I think the part here where you got the sum, because the sum is currently X. If you look at this part here, Vn is set to X and sum is set to the Vn. And because we're starting out, then we know that this is X. And then we need to add the new Vn from here. That's why what we get is x plus, in this case, negative Vn, negative x times x divided by 3, or what we get would be negative x squared divided by 3. Now if you move on, because we haven't satisfied the condition to stop our while loop, then our current k is 3, then we do another plus 2, that's why we get 5. Now for sum, what we get would be the current value of sum, which is this one. We got it from here, and then we have to do a minus Vn times x divided by k, but because this one is negative x squared divided by 3, then we would get a plus here instead of a minus only, because this is negative and this is negative as well. And so what we get would be a plus x squared divided by 3, and then we need to multiply it with x divided by 5, where 5 is the k. That's why what we'll get would be this x plus this one. Actually, I think we can disregard this one. Don't need to add it. But I think in my case, while I was looking for the answer, I ended up doing something like this, seeing some kind of pattern. Okay, so we can put them together in this way. But eventually, we needed really to put them together. So that's how I got this. But if we look at our intended output, we need to have x divided by 1 factorial, which is x, minus x cubed divided by 3 factorial, plus x to the 5th divided by 5 factorial. And if we look at our output, we don't see that here. We don't see that 3 factorial, which should be 6. And also for this one here. That's why this would be wrong. Now, our next option is maybe we can do a square here and a square here too. See if that would make any change. That would be closer, or if not, the actual output that we're going for. Because remember, we need to get a 6 and we need to get 120 in our outputs. 6, so, and then 120, maybe we can get closer to that. Now if we try it out, our k again starts at 1, we do a plus 2, we get 3, and then in this case what we're doing is we got minus bn, which is currently x, so minus x times x squared divided by 3 squared, our k. That's how we get x plus minus x cubed divided by 9. We go to the next, where k is 3 plus 2. Previously k became 3, that's why when we got here it's 3 here plus 2, then that's why it's 5. And then remember, we have this part here, this part, so that's why it's also here. And then we need to get this here, this one here, and that's why we have it here. But remember that this is minus, so we have to do a minus here, and then we have to multiply it with x squared and divide the whole thing by k squared. That's why what we'll get would be x minus x cubed divided by 9 plus, because this one, put them together, becomes positive. Then we need to multiply x cubed with x squared. That's why we get x to the fifth. Then this one's 9, and because k is 5 and we're dividing the whole thing, then to get the answer, what we can do is to make this 1 divided by 25. And so what we'll get would be 9 times 25, which is, I did the computation in this way, 9 times 5, okay, 9 times 2 plus 4, 225, that's why I got 225, and x to the fifth times 1 is x to the fifth. But again, the answer is not quite what we are going for, because the output again should be 3 with the one at the bottom. The denominator would be 3 factorial and then 5 factorial, right? I think we can get that x cubed and x to the fifth in this case. See, we could get it in this way, but the one at the bottom isn't supposed to be these two. Okay, now finally we can check the correct answer, and this time we have another equation, and I think that the square here somehow got us the top portion right. Now we need to check whether we can get the bottom part right too. So if we are starting off with our program, then this would be 1 4k, and then we have to add a plus 2, that's why it's 3, and then we put in the values in our equation. So this would be put in this way. The Vn is currently at, let me see if I can get it right, minus Vn. So this is x, and then multiply by x squared, so that's why we got x squared, and then 3 minus 1 times 3. So 3 minus 1 is 2 times 3, that's why we have this. Now if we put them all together in this way and get the, for example in this case 2 times 3, we get 6 as the product, and then in this case x cubed. So that would be when we are starting with k is equal to 1. Now if it's k is equal to 3, then we do a plus 2 and it's 5. Then this part here, we need to put it here, and then we need to add this part where this one is currently negative and this one is negative, so we got minus and minus that in this way, and then multiply it with x squared divided by 1, and then divide the whole thing by this part. So it's 5 minus 1 times 5, which gives us 20. 4 times 5 is 20. So if we continue on with this, we will get, this one will be minus, and then this one would be x cubed divided by 6 times x squared over 1. Then what we'll get would be x to the fifth, and then divided by 6. And then this word here, we need to divide it by 20, the whole thing. That's why we can get this. And then at the end, what we'll get would be multiply these two, okay, x to the fifth, and then 6 times 20 gives us 120. And if we look at the pattern that we're going for, x divided by 1 factorial is this one, minus x cubed divided by 3 factorial, it's this one, and we have to do a plus. X to the fifth divided by 5 factorial gives us this. So the correct answer would be letter H. And just in case you don't quite remember how to do the exponents, I think you can look it up at mathisfun.com. But remember, when doing the exam, you're not supposed to use the calculator nor check any website to see certain explanations for something like this, like how to do the exponents. And I think in this case, if you can solve it, then I think you should be able to get the point, and maybe more than just 1 point for this question.